According to the National Electrical Code, it is not legal to use number 14 wire to supply a 20 amp circuit. The NEC requires that the wire size for a 20 amp circuit be number 12 AWG or larger. Using number 14 wire on a 20 amp circuit is a serious safety hazard. Number 14 wire is not rated to carry the current that a 20 amp circuit can draw. This can cause the wire to overheat, which can lead to an electrical fire. To comply with code and ensure safety, firstly, replace the number 14 wire with number 12 wire, and secondly, ensure that the circuit breaker or fuse protecting the circuit is rated for 20 amps. In addition to the NEC, local building codes may also have additional requirements. It's important to check with your local building department for any specific regulations that may apply. It's highly recommended that you seek the assistance of a licensed electrician to correct this issue. Electrical work can be dangerous, and it's essential to have it done safely and professionally. The National Electrical Code, or NEC, sets the standard for safe electrical installations in the United States. Its purpose is to protect people and property from electrical hazards. Understanding and adhering to the NEC is crucial for anyone working with electrical systems. Wire size is a critical aspect of electrical safety. The wire must be able to safely carry the intended current. The ampacity of a wire, which is the maximum current it can carry without overheating, depends on its size and insulation type. Using a wire that is too small for the circuit's current can cause the wire to overheat, potentially leading to a fire. Circuit breakers and fuses are overcurrent protection devices. They are designed to interrupt the flow of electricity if the current exceeds a safe level. This protects the wiring and equipment connected to the circuit from damage due to overload or short circuits. A 20 amp circuit breaker is designed to protect a circuit wired with number 12 AWG copper wire. Using a 20 amp breaker on a circuit wired with number 14 AWG wire is unsafe. The number 14 wire can overheat before the breaker trips, creating a fire hazard. Number 14 AWG copper wire has an ampacity of 15 amps at 60 degrees Celsius, 20 amps at 75 degrees Celsius, and 25 amps at 90 degrees Celsius, according to NEC Table 310.15b16. Number 12 AWG copper wire has an ampacity of 20 amps at 60 degrees Celsius, 25 amps at 75 degrees Celsius, and 30 amps at 90 degrees Celsius, according to NEC Table 310.15b16. It's important to note that these ampacities are for copper wire. Aluminum wire has different ampacity ratings. Local building codes may have additional requirements beyond the NEC. It's always a good idea to check with your local building department to ensure that your electrical work complies with all applicable codes and regulations. If you're not comfortable working with electricity, it's always best to hire a licensed electrician. Electricians have the training and experience to safely and correctly install and repair electrical systems. Working with electricity can be dangerous, and it's important to take all necessary precautions to protect yourself from electrical shock and other hazards. Always turn off the power to the circuit before working on it. Use insulated tools and wear safety glasses. If you are not sure how to do something safely, ask an electrician for help. Replacing the number 14 wire with number 12 wire involves several steps. Firstly, turn off the power to the circuit at the circuit breaker. Secondly, remove the existing number 14 wire from the switch and outlet. Thirdly, install the new number 12 wire, making sure to connect it securely to the switch and outlet. Fourthly, turn the power back on and test the circuit to make sure it's working properly. When working with electrical wiring, it's important to use the correct type of wire connectors. Wire connectors are used to join two or more wires together. There are many different types of wire connectors available, each designed for a specific purpose. Using the wrong type of wire connector can create a loose connection, which can cause the wire to overheat and potentially start a fire. It's also important to properly tighten the wire connectors. Loose connections can also cause overheating and fires. Use a torque screwdriver to tighten the wire connectors to the manufacturer's specified torque. When installing electrical outlets and switches, it's important to follow the manufacturer's instructions. The instructions will tell you how to properly connect the wires to the device and how to mount the device in the electrical box. It's also important to use the correct size electrical box for the device. The electrical box must be large enough to accommodate the device and the wiring. Overcrowding the electrical box can cause the wires to overheat. When running electrical wiring, it's important to protect the wire from damage. Run the wire through conduit or use cable staples to secure the wire to the wall or ceiling. Avoid running the wire in areas where it could be damaged by nails, screws, or other objects. If you're running the wire through a wall or ceiling, make sure to drill the holes in the studs or joists so that the wire is not exposed. When working with electrical wiring, it's important to be aware of the potential hazards. Electrical shock can be fatal. Always turn off the power to the circuit before working on it. Use insulated tools and wear safety glasses. If you're not sure how to do something safely, ask an electrician for help. Grounding is an important safety feature of electrical systems. Grounding provides a path for electricity to flow back to the source in the event of a fault. This helps to prevent electrical shock and other hazards. All electrical outlets and switches should be properly grounded. The grounding wire is typically green or bare copper. It should be connected to the grounding terminal on the outlet or switch and to the grounding bar in the electrical panel. Arc fault circuit interrupters, or unsafe, are a type of circuit breaker that is designed to protect against arc faults. Arc faults are a common cause of electrical fires. An arc fault occurs when electricity jumps from one wire to another, creating a spark. Unsafe are designed to detect these sparks and trip the circuit breaker, preventing a fire. Unsafe are required in many areas of the home, including bedrooms, living rooms, and dining rooms. Ground fault circuit interrupters, or GFCIs, are another type of circuit breaker that is designed to protect against electrical shock. A ground fault occurs when electricity leaks from a circuit to ground. This could happen if someone touches a live wire or if there is a short circuit. GFCIs are designed to detect these ground faults and trip the circuit breaker, preventing electrical shock. GFCIs are required in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor outlets. When working with electrical wiring, it's important to use the correct size and type of wire. The size of the wire is determined by the amount of current that the circuit will carry. The type of wire is determined by the application. For example, non-metallic sheet cable, or NM cable, is commonly used for residential wiring. NM cable consists of 2 or more insulated wires wrapped in a plastic sheath. Underground feeder cable, or UF cable, is used for underground wiring. UF cable is similar to NM cable, but it is designed to be buried directly in the ground. Conduit is a metal or plastic pipe that is used to protect electrical wiring. Conduit is required in some applications, such as in areas where the wiring is exposed to physical damage. There are many different types of conduit available, each designed for a specific purpose. Electrical metallic tubing, or IMT, is a thin-walled steel conduit. Rigid metal conduit, or RMC, is a thick-walled steel conduit. PVC conduit is a plastic conduit. When installing electrical wiring, it's important to follow the NEC guidelines for spacing and support. The NEC specifies the maximum distance that wiring can be run without support. It also specifies the type of support that must be used. Following these guidelines will help to ensure that the wiring is properly supported and protected from damage. When making electrical connections, it's important to use the correct type of wire connector and to properly tighten the connection. Loose connections can cause overheating and fires. Wire connectors are available in a variety of sizes and types. Choose the correct connector for the size and type of wire that you are using. Use a torque screwdriver to tighten the wire connectors to the manufacturer's specified torque. When working with electrical panels, it's important to be aware of the potential hazards. Electrical panels contain live wires and components. Always turn off the power to the panel before working on it. Use insulated tools and wear safety glasses. If you're not sure how to do something safely, ask an electrician for help. Electrical panels should be properly labeled to identify the circuits that they control. This will make it easier to troubleshoot problems and to turn off the power to specific circuits when necessary. Use a circuit directory to label the circuits in the panel. The circuit directory should be located on the inside of the panel door. Electrical panels should be inspected regularly to ensure that they are in good condition. Look for signs of damage such as corrosion, loose wires, or damaged components. If you find any damage, have it repaired by a qualified electrician. When adding a new circuit to an electrical panel, it's important to make sure that the panel has enough capacity. The capacity of a panel is determined by the size of the main breaker. The main breaker protects the entire panel from overload. If you add too many circuits to a panel, you could overload the main breaker, which could cause a power outage or a fire. If you're not sure whether your panel has enough capacity, ask an electrician for help. When working with electrical wiring, it's important to follow all safety precautions. Electrical work can be dangerous, and it's important to take all necessary steps to protect yourself from electrical shock and other hazards. Always turn off the power to the circuit before working on it. Use insulated tools and wear safety glasses. If you're not sure how to do something safely, ask an electrician for help. The NEC is updated every 3 years. It's important to stay up to date on the latest changes to the code. You can purchase a copy of the NEC from the National Fire Protection Association, or NFPA. You can also find information about the NEC on the NFPA website. Electrical safety is everyone's responsibility. By following the safety precautions outlined in this video and by staying up to date on the latest changes to the NEC, you can help to protect yourself and your family from electrical hazards. Remember to consult with a licensed electrician for any electrical work that you are not comfortable doing yourself. A qualified electrician can ensure that the work is done safely and in accordance with all applicable codes and regulations. Always prioritize safety when working with electricity. The potential consequences of electrical accidents can be severe, so it's crucial to take all necessary precautions to minimize the risk. By understanding the principles of electrical safety and by following the guidelines outlined in the NEC, you can help to create a safe electrical environment for yourself and others.